Okay, so let's talk a little bit about torque and moment of inertia. Just to kind of like get us started here, I'm going to start this top. So I'm going to hold the block steady and apply torque to the string. The object will resist spin. It's called its moment. And then after I've applied this torque for a certain number of seconds, we should be able to figure out how many RPMs the top has. So here goes. And so the top is now spinning. It's got quite a few RPMs. You can see it kind of processing around there. It's coming to attack me actually. And we're going here. So, you know, what's going on here? Well, we have a few things. The major idea is that torque is equal to force times radius, which is also equal to I times alpha. So that's kind of weird because torque is equal to two things. Every top or every object has a different I, which is its moment of inertia. So it doesn't really matter what you're talking about. It should have a different I. That's the one thing that's the same for everything. So like this top, we could then, measure its radius, and then we could put it on a scale or something. So I comes from both the mass of the object, in this case it was like a little top, and the radius of the top. So we'd have a certain number of kgs here, and we'd also have a certain number or certain radius. And so those things put together would give us mass and area. And you can use your formula sheet if you like, and try to classify your object. Different objects have different moments, whether it's a uniform object like this, which would obviously be like a disc, or we could have other objects that are more hoop-like or ring-like, or even more of a solid ball. You have to kind of go through and make sure you know what you have. The other thing is force. So I control that by how many newtons I pull, the tension in the string, and then where I wrap the string from will tell us kind of the radius. So since I'm wrapping on the shaft or the axis of rotation, this radius would be a different radius than maybe we would use up here in this equation. So, in speaking of this top, when we're doing this radius here, we're talking about the radius of the shaft. When we're doing the radius to calculate the moment of inertia, we're talking about this larger radius. So we could calculate torque. Torque is usually measured in newtons times meter. And then we can set the torque equal to I times alpha, which will allow us to solve for alpha. Once we know what alpha is equal to a change in W over T. In the example I just showed you, we started from rest, so W final minus W initial. If we start at rest, we get rid of that. The time that I pull the string for would go in there, and we could calculate W. Once we're in radians per second, or W, it's just a matter of multiplying by 2 pi, multiplying by 60 and dividing by 2 pi. I would do quantity 2 pi if you don't want your calculator to mess up. And that'll tell you how many RPMs you have. So that's how we apply this equation. You have to do it in a certain way. We'll be doing this in our class, and everybody will be finding the number of RPMs they have for their particular top.